Morris, one of the coordinators at ACAN, and it's great to welcome you all today to the halfway mark of our circular series. The response to the series so far has been excellent, and we're really excited about the ongoing work that this will be leading to. Just a quick bit of housekeeping. The meeting is being recorded, so to avoid any background noises, mics will be kept muted. However, we do want to hear from you. So if you have any questions for our speakers, please type them into the chat box and we'll try to get to them later. If you aren't familiar with ACAN, ACAN is a network of individuals within architecture and the built environment taking action to address the twin crisis of climate and ecological breakdown. We have three overarching aims: decarbonise now, ecological regeneration, and cultural transformation. Our growing network is formed around thematic groups, and last week the 9th one launched, Natural Materials. We work together to create change in many ways, including campaigning, research, lobbying, and knowledge sharing. If you'd like to join any of these groups, please do join the WhatsApp and Telegram broadcast channels, which should be being posted in the chat now. We have some live campaigns at the moment that you can go ahead and support. All links are going to be posted in the chat box. Limit the carbon footprint of construction, campaign launched successfully with cross-industry support. And we're 211 signatures away from reaching a target, so do please go spread the word on that. Also, ACAN recently assisted the Green Party in preparing the parliamentary petition of VAT reform to create a tax incentive to favour retrofit instead of demolition and new build. So please do join us to push Parliament for action on this. Our thematic groups have many other exciting initiatives and collaborations underway, although we don't have time to shout all of them. Please do get involved and be part of the action. ACAN Circular Economy Group is focused on how circular economy principles can be applied to the UK construction industry, identifying opportunities, examples, plus some of the many barriers to implementing circularity in the UK context. The number of attendees throughout the series suggests very many of you, like us, are enthusiastic about circularity in theory, but finding it difficult to implement in our construction projects. We found experts from across the industry to dig down into the details of how to incorporate circularity in a meaningful way at each RIBA stage, from 0 to 7. And we plan a final event to develop a proposal for a new stage 8, closing the circle with disassembly and reuse. Tickets for the next event are available, so do go grab one. All of our previous events are available to watch back via YouTube channel, along with this one and the future events too. For context on today's event, here's a quick reminder of Stage 4 technical design, taken from the RIBA Plan of Works. In Stage 4, the design team further develops the Stage 3 developed design in sufficient detail for tendering and construction assembly activities on site. If the design activities are to be undertaken by a specialist or subcontractor, then the design will need to be developed to a level that allows for this, and the design team may have obligations to check this information or respond to the design queries as set out in the design responsibility matrix. The technical design will include the required construction details, choice of materials, and standards of workmanship. So for today's event, we're delighted to be joined by Dr. Elma Durmisevic, an architect who's the head of 4D Architects in Amsterdam, where she has developed 2 EU circular building demonstration pilots, which demonstrate the implementation of reversible circular building design approach in real construction projects. Elma is also the founding director of the Laboratory for Green Transformable Buildings in the Netherlands. This is a platform for circular buildings. She is the founder of Green Design Centre for Southeast Europe and published the first PhD dissertation and book on design for disassembly in Europe. Over the course of 20 years of research with numerous EU projects, Elma has developed tools for measuring circularity and reversibility, which are integrated into the EU guidelines for designing circular buildings. Elma led the EU Horizons 2020 BAM, Buildings as Material Banks, reversible building research, and is a member of a number of juries and scientific committees. And our second speaker, Nitesh Magdani, who has over 20 years of experience working across the areas of design, construction, and property development, acting as architect and sustainability expert. He has also had leadership roles at the Royal BAM Group and the Supply Chain Sustainability School. Nitesh works with clients and stakeholders to create solutions towards a net zero and circular economy future. Nitesh developed a circularity economy strategy at BAM, including BAM's engagement with the Ellen MacArthur Foundation, co-authored a publication on circular business models, and has been influential in several circular economy projects, both in the UK and the Netherlands. Finally, before we hand over to the speakers, we also have an interactive Miro board to which everyone is invited to contribute and continue the discussion. Unanswered questions from the chat will be posted here, and the speakers will have a chance to answer them after the event. This will be forming the basis of a resource we'll produce at the end of the series, so all contributions are very welcome. We'll post the link in the chat now. The Miro board will be open for the next 2 weeks, so please do check in and continue the conversation. Elma, over to you.
Hello, thank you, Mathieu. Can you see my presentation?
Yes.
Yeah. Thank you for inviting me to speak at this event and for the time. It is restricted time, so I'll just start on immediately with the talk on the subject and ideas I want to share with you and the audience today. So I want to talk about reversible building as I see that as the new generation of the building, the way that we should be looking at the built environment if we want to move towards circular building and circular world. And obviously, for me, the reversible building is something that brings a new perception on the way how we see built environment. Conventionally, buildings have been designed as static structures. We see them as static structures, which are designed for one end of life. That means that with every iteration, adaptation, demolition needs to take place. And the reversible building, in opposite to that, brings in a view on a building and building structure as a dynamic structure, which is built up of exchangeable parts and modules, which can be recovered and reused, recycled in new cycles. And it brings this view, sees a building as a multiple layer and building gains in such a way multiple future capacities and value propositions that I will present and talk to you in these 15 minutes. I'll try to be sharp. But the reason why I was myself very fascinated with this approach and obviously been working on this issue of flexible, transformable, reversible buildings, we call them now circular buildings, is the kind of fundamental mistake and error I think we have built into our design of buildings and construction. As I said, we see buildings and design them as static structures, but the very purpose of building is to provide an envelope and comfort for human activities, for human life. And somehow we think that all these changes and ever increasing changes of life and way of living can fit into that once designed structure, which is not designed to be recovered or adapted or materials reused. If we just see look at this diagram, I just want to simplify the discussion for next slides. What we are talking about is, if you look at our human life, we go through a number of life phases, 7, 8 life phases, and every of these life phases require something else from our built environment. That means some changes. We want to adapt our space. And that is, to my mind, in contradiction to the way how we design buildings. We do not design these capacities. We do not design with these capacities, changing capacities in mind when we design buildings in general. And that's the reason why we end up with massive demolition processes. When we look at the cities, streets, this is the only end of life which is still kind of happening through cities in Europe. And that is mainly because buildings are not designed to be adapted to new requirements, technical changes, technological changes, or its parts cannot be recovered and reused. And of course, obviously, I will not go through these details, but I'm sure you all know that this results in huge negative impact on the environment and economics in the end as well. So that's what we want to change. That's why we want to come up with a new approach where I would say demolition for me, if I see demolition happening, I would say there is a design mistake. It's, for me, demolition is a result of design mistake. And it is on a design table where we define how the building will look like, but also how its configuration will be put together and how the materials in the future will end up. So if we didn't think through carefully about the future scenarios for buildings and their materials, then demolition will happen. And I hope with all tools that we've been developing in the last decade, we can help to start taking this design mistake away from the tables. So in the future, I think the nice view would be to see built environment as upgradable dynamic, this upgradable environment, where the construction is not organized around demolition of buildings anymore, but about around transformation and upgrading of buildings, reconfiguring its parts and bringing them back into built environment again. So that would be kind of where we would like to go. But in order to do that, we need also changes on different levels, but starting from clients as well. When we receive a design brief, we would need to ask clients to come up with a number of design or use scenarios. In this case, I'm just showing one project we did in the Netherlands with the Housing Corporation, where we asked the Housing Corporation to provide us a design brief with a number of possible use scenarios which come out from the demographic studies of the city and area where they looked into future needs and scenarios and what kind of families will be living there. Based on that, they came up with 4 scenarios. And based on that, when you have kind of options for the future that also client look at carefully, you can start developing a system for the building that can live longer, that can accommodate these 4 different scenarios and does not have to be demolished and wasted, but can be adopted for a next user. But same counts for the technical parts and systems. That means that in the future, we would need to design systems or units for buildings which can accommodate different techniques, answer different energy performances, be made and filled in with different materials. So reconfigurable systems, as this prototype we've done also for extension units. In the Netherlands, same counts, just staying on the technical level of systems. Bathroom system, for example, again, a design for nursing home based on the number of scenarios, how the bathroom can be changed over the use of the building as a nursing home, so that you can adapt bathrooms without demolishing them and bringing in new materials. So this brings on the new tasks for architects and designers, and the task would be to ensure, in my mind, to ensure multiple value propositions of building through design of multiple dimensions of transformation. And these dimensions are supported by high disassembly and reuse potential. And that brings me to the 3 design dimensions that I think designers and architects should be looking at when designing future buildings. I call them 3 dimensions of reversibility: the reversibility of space, this adaptation of space, reversibility of structure, the reversibility of material as a 3rd dimension of reversibility. These 3 dimensions of reversibility are structured around the core of circular and reversible building, or that will enabler of circular building, which relies on 2 key pillars: adaptability and reuse, supported by disassembly. This main core, basically, and the way how we as designers answer these 3 key elements that are enabling circularity, adaptability, reuse, and disassembly will inform us on the performance of the building and the system in the future. And by analyzing and assessing these 3 key elements, we can structure and the whole built environment and group it in three general groups from being irreversible to reversible. So that was a framework that I developed also to a number of European projects to help move further. And when we talk about the future circular buildings, on one hand side, we need to design them. Thus, we need new design guidelines and protocols. And on the other hand side, once we have designed and built buildings, we also need measurement tools in order to measure the performance of these new buildings. Because we are talking about new buildings, we don't have means to measure their performances. So we need to develop also the tools to measure these performances. So that's why I developed a kind of reversible building toolkit with a couple of basic tools, which I thought were kind of essential to start with. On one hand side, developing protocols and design guidelines that will help designers from initial stages to the end to design more circular reversible buildings. On the other hand, to support the design, especially, for example, the preliminary design phase, the transformation capacity tool has been developed with supported virtual simulator. It is BIM-based, and technical reversibility is more part of technical design phase and final technical design phase, which is supported with reuse potential tool, which also assesses the performance of the design in the end. So you can improve your design when using these assessment tools. So this is the basic design toolkit. And when I map it against the three designs, the dimensions of reversible design, the first one, transformation capacity, this addresses the design of adaptable spaces. It measures the ease to adapt the building and change the function without demolition. It's more on building level. The other one, the reuse potential and reversible BIM, I'll mention that shortly in this presentation, is helping this to go through the final and technical design stages in terms also assessing the design solutions and improving them where needed. And then they look, this is the general distinction categorization of design phases, which we have in the Netherlands. I think that's quite similar to what you have in UK from preliminary design phase. So these more transformation related indicators as the dimensioning of the block, position of the core elements and core capacities and so forth, important parts and aspects of design this phase. I will not be talking about these today. And today I will be talking and mentioning more the blue parts. Those are indicators for design for disassembly and design of reversible building structures. So the second part, which is, as you've probably seen in one of the slides, the building has its spatial parts. I call that spatial reversibility. We need to pay attention for that. And the technical part, what makes building in the physical sense, it's a technical part. And in terms of circularity, we talk about technical reversibility of the building. In order to design this technical reversible systems and products, there are three key design domains that design of each configuration of product will go through and has. Those are functional, technical, and physical design domains. And when we want to design for disassembly and for high reuse potential, what I've done, and I developed a model obviously for that, I developed a model which analyzes three types of dependencies that occur in every product structure. Those are functional dependencies, technical dependencies, and physical dependencies. The schemes you see here are kind of general information on what kind of analyses are taking place in these domains. This design of every product, whether we talk about building as a product or system or component as a product, as these three domains, and within every product structure, I call it also configuration, number of dependencies occur between parts. And these dependencies, if they are not dealt with properly during design, will result into dependencies that need demolition in the end. So based on that, I defined 8 design aspects that are related to each of these three groups: functional, technical, and physical dependencies. So where do we need to look at, and how can we deal with that? I'll go through very fast through these few of these design aspects. But on the other hand, these 8 design aspects are also indicators of reuse potential and technical reversibility. That means by assessing each of these indicators, we measure reuse potential of building itself. And the number of reuse potential, which is between 0.1 and 0.9, it is related to the end of life options that element will have. So if the element has reuse potential of 0.3, that means it will be recycled, for example. So the reuse potential maps reuse options and strategies for the materials based on the whole life cycle of material. So that's a part of the evaluation. And when just looking at the 8 design aspects, I'll just run through them. Sometimes visualization helps. Something stays in your mind. When I talk about functional decomposition, obviously the separation of functions on a building level, but also on system level, is something that needs to be taken care of, but also integration of functions in terms of installation surfaces and a structure. Systematization is very much about modularity, how modular is a building and on which level it is, the hierarchy and hierarchical pattern which emerges within configurations is very, very important part, which plays an important role when we think about taking a part out. As you can see on left-hand side in the upper corner, a very complex diagram where all elements are interconnected. Mainly existing buildings have these kind of complex diagrams. It means if you want to take one element out, you have to cut 5 or 6 connections, the reason why we demolish buildings. The base element specification is something which really helps to sort out this complex relational diagram and define a base element in your configuration system that will be intermediary between other elements which have different functions with different life cycle. Or product edge, geometry of product edge is another indicator, which will also sometimes be a barrier for recovering element out without demolishing it or damaging it. Assembly sequences as well, very often we don't think about that, but the way we design also the connections will have impact on whether we put in place a configuration which will be assembled in sequential order. Means if you want to take one facade out, you need to take 15 elements away, or it's assembled in parallel order. And the type of connections, of course, there are a number of these to take into account from reversible to irreversible. As a designer, if we go through these 8 indicators, we can create a net graph which will indicate the ones which can be improved, the aspects which can be improved if we want to have building or a system with higher reversibility. This approach is used on one hand side as a design tool, design support tool. But on the other hand side, as I mentioned, is also an evaluation tool. This, indicators are used to create a measurement tool to measure those dependencies and reuse potential of elements in the building. And these 8 indicators, which I mentioned, are listed here on your left-hand side. They have a number of sub-indicators, and the assessment is optimized in this case in Excel to measure reuse potential on building system and product level. It's quite a complex process, I can tell you that. And that's the reason why I also started to integrate this assessment process into BIM and developed something which is called the Reversible BIM. I still work on that, but we have tested that on a couple of buildings. And what the Reversible BIM is doing, basically, we tested it on existing building by scanning an existing building and getting the point cloud files, and then creating the Reversible BIM according to the reuse potential methodology, functional decomposition, and so forth. So this is kind of basic, this kind of model, which we use to add plugins, which we developed as well, plugins which analyze the number of connections, for example, within elements, and colors the elements. The elements which have up to 3 connections are green, or more than 7 are red, and that's presented in the model itself. The BIM also, we developed another plugin for connections to analyze the types of connections, also related to color coding, and actually it's all related to the methodology of reuse potential I mentioned in the previous slides. And then putting all together, reuse potential is calculated, and color coding files are created for viewing. And when you click on each of the elements, you get your reuse potential scoring, and that helps you to have an idea of how many elements you have in a building with high reuse potential. It's for the construction companies quite interesting. They can create also their deconstruction strategies based on this analysis. But for the architects in the future, we are thinking of developing the 3D library of BIM objects, which for the elements which have high reuse potential, so they can be directly used in new designs. And this reversible BIM is now being placed and integrated on a platform which is called Digital Deconstruction Platform, together with 3D scanning, digital material passport, and blockchain, in order to support the decision making, mainly owners of the buildings and the construction companies, to define their reuse and the construction strategies in the future. So that's how the assessment looks like, and how it looks like now in a BIM as well. But I think more importantly for designers is also to look into what the implementation of a design aspects can mean. And that's why I have a couple of slides of demonstrators where we demonstrated the results of design process, where these 8 indicators have been consequently integrated through the all design phases, creating these modules with independent parts and systems, and going back to the independency and reversibility, not only of major components of the system, but also reversibility of subsystems as well. What you can see here, we transformed this module, for example, into a model with a terrace, where the facade has been reversed and became a terrace, and the door is not more a door, or becomes a window, or something else. And everything is done without any additional screw or material used. It also brings us to the to think about new materials, new geometries, new connections, and this is one of the connections I've been working on with the Janssen and ODS. Obviously, trying to bring in some new products which will help future reversibility of buildings or improve these. So new products need to be developed as well, or development of new systems. So this is a bio-based facade system, also following these 8 indicators, or design of whole building as a green design center I have here, and laboratory for green transformable building, which is under construction at this point. So this, I don't know how many minutes it took. I hope not too many. This is my last slide.
Excellent. Thank you so much for that presentation. It's really good to be able to dive into some of those details and look at the precedents and tools that you've actually developed so far. They're thoroughly thought out. If you have got any questions for Elma, please do post them in the chat and we'll pick them up at the end. So next we'll be hearing from Nitesh, but whilst he is setting up, we'll be issuing a small poll which should appear on your screens. It'll be good to know a little bit more about our audience and who's attending. So Nitesh, over to you when you're ready.
Great, thank you, Matthew. And let me just share my screen. Okay, can everyone see that?
Yes.
Okay. I'll wait till the poll's finished.
think you probably crack on with that, Nitesh.
Yeah, okay. Let me just move that out of the way. Okay, well, thanks for the introduction, Matthew, and thanks for inviting me to speak. What I wanted to talk about today was, I knew I was following Elma, and I know Elma very well, so I knew hers would be sort of very technical in terms of giving you hints and tips as to the reversible building potential, etc. So I've focused on the business model side of things, and especially from my experience at BAM, having worked in the Netherlands with Elma and others on BAM-B, but also working on live projects, being exposed to a few. So really, I want to touch on drivers for change or challenges, and then talk about a couple of case study examples from my experience at BAM, both in the UK and also the Netherlands. But then also some examples of different value-based procurement methods that we've used, and that in itself gets you to a different outcome. And then at the end, just a couple of post-its showing opportunities, business models, etc. So just moving on. Let me just, yeah. So this is a quote from Sir Nicholas Stern. I'm not going to read it out for you, but as an economist, Sir Nicholas Stern, he quite rightly linked our linear consumption patterns with market failure, and that's measured as what we'd say is financial wealth. And also, as highlighted a few weeks ago by the Gusgupta review, which some of you might have seen, we need to fix this disconnect between GDP or financial wealth and natural capital. And that doesn't just go for natural capital, it's sort of human capital, social capital, etc. And having that understanding, or the broader understanding of how we shift from having a very short-term mindset to looking at long-term value. And if you do something on this side, let's say you increase the biodiversity on a site, or you design for deconstruction, how does that affect social capital, human capital, or how does it affect your financial capital over the life cycle of a project? And that's really where my focus is sort of understanding and helping clients to understand that value, but also where they can see an opportunity, or how to identify that opportunity going forward. So I've selected a few of the projects that I've been exposed to at BAM to highlight that point around value, and how we can turn that into a competitive advantage, essentially. And also, whilst I agree with Elma's presentation, and you do need to start with design, circular economy is broader than just design. It's not just about designing something. It also requires a lot of collaboration, systems thinking, and opens the door to, as I've said before, new business models. Okay, so in terms of challenges, and again, these are not exhaustive, but I suppose one of the issues that we deal with, or we need to deal with, is the lack of briefing and the lack of outcome. For example, if we look at short term, sorry, that was the delivery. So if we take short term view, is the asset required? Is it flexible? Have we thought about end of life? Utilization. So have some forethought as to meanwhile uses, or land use and value of land. How can we utilize the land to benefit society? Maybe think about provision of land, or air, water, biodiversity, resources, and climate. And then depletion of natural resources. So taking a whole life carbon approach in the broader sense means to strive for a balance between emissions and production. So if you look at the energy hierarchy, there's also a waste hierarchy. How can we work through that and incentivize, reuse, repurposing, etc., before recycling, and then ultimately, sending something to landfill. And again, as Elma pointed out, waste is a mistake. Waste is material in the wrong place. So circular economy opportunity to, well, the circular economy opportunity to reuse materials is to identify new products and services, is to look at the sharing economy or performance economy, and also just to shake up the way we do business now, because it's not going to change just by, designing in a different way if we have the same contracts, the same level of incentivization through, tender, procurement, etc. Okay, so a couple of examples or case studies, let's say, from my time at BAM. So Circle in Amsterdam, it was a building for ABN AMRO, the bank, and they basically wanted to invest in sustainable investments. So they had, I think, 2 million euros that they had to invest by 2020 or something. But to do so, they needed the evidence base, and they wanted to demonstrate what circularity was. So we went on this journey with them, with an existing architect, and the design at the time was all concrete. It was pretty much a concrete box, and whilst it looked really elegant, it wasn't designed around life cycle thinking. It wasn't designed to be reused. So we did look at reuse, take back, performance contracts, etc. And we tried not to make it a fully circular building in one sense or the other. It was just a case of testing different theories. So we got involved quite early, and we, together with the supply chain, getting others involved quite early on, whether they were BAM's original supply chain or more likely, suppliers that we hadn't worked with before. And we really focused on, how to get the best value in a project. So we put together a procurement evaluation matrix, basically a spreadsheet. So it's not as sophisticated as Elma's approach, but it worked. And it was really just around having that transparency between all the different players around the table. And actually we looked at a 25-year life cycle model. And it's not to say that after 25 years, the building was going to be demolished, but it was just to say after 25 years, what would happen, if we wanted to dismantle some of the building materials or create new contracts, performance contracts, etc. How would that happen? And that led us down the path of the materials that you can see there, which were very much around glulam beams, CLT, facades which were clipped in place. We tried not to glue. I don't think we glued anything, really. Everything was surface fixed. And it was really around the design thinking, the exercise that we had to go through, as you do with, looking at air tightness, fireproofing, etc. This was about how to design with disassembly in mind. And also we published a report through the Ellen MacArthur Foundation called Circular Economy Business Models in the Built Environment. And that was to basically demonstrate that if you take a linear model and convert that to a circular model, how does that change the incentivization or the benefits to the designer, the supplier, the asset owner, user, etc. So that was quite, a good, case study really in terms of just identifying the value proposition, not just for the end user, but for the other, understanding what the designer needs to do to change, to sort of shift, from thinking about things in a linear way to circular. Another project was the circular building, which we constructed in London. And that was just outside the building centre in 2017 for the London Design Festival. So we did that with Arup, the Built Environment Trust, and Fenner and Reifer and BAM. And basically we focused on design for reassembly. So again, just as with Elma's presentation, we were not focused on design for disassembly. We were focused on how do we design something, and let's say the waterproofing, FATRA waterproofing. We had various design workshops with them to ensure that we could design it using their products, as well as all the cradle-to-cradle products that we used elsewhere, disassemble that those elements and then be able to reuse them again in a different situation. So that was quite eye-opening, just as a process, because there was a lot of workshops and just thinking through, not just how do we put this together, and we're not trying to glue it all together, but we want to design it so that it can be used again. And it did need that commitment from the whole team to understand the business models for them. So some of the discussions were around getting them to understand the remanufacturing process if they were to take the material back. And then another project, which I think this is the last project that I'll show you. This was a huge property development project that BAM are doing now. And basically a few years ago, they bought the site for 85 million euros, designed by SOM, I believe, the master plan. And basically this was a bid that sort of was put forward to the sort of Amsterdam City Council, and 50% of the acquisition of the land was based on quality. And again, that sort of just goes to show that the change in mindset between the UK and the way that we procure for financial gain, let's say, very short-term thinking, against in the Netherlands, we were incentivized to put forward a bid that had was very high on quality, very high on life cycle thinking. So we focused on getting as much of the existing land, and at the moment there's a prison that sort of has been there for the last 30 years or so, 40 years maybe, made out of concrete, steel bars, etc. Which we're sort of looking at solutions with various providers of concrete, for example, looking at how we can demolish or reuse or take down the concrete panels and then start to reuse them, whether it's crushed down and reused as concrete again, as aggregate, or reused in their original form as panels. And then the jail bars, some of them will be balconies or bridge, balconies around bridges as well. So again, we were incentivized to put forward all of these proposals, but also to work with our supply chain to make it happen. And then finally, the other example that I wanted to show you was the amount of supply chain engagement that we had to do. So as a construction company, we had to engage with a lot of our supply chain, or we wanted to make sure that it was not seen as BAM are doing circular buildings. You can't do that. I mean, literally, without having your design team, your supply chain, understand the impacts and the consequences of designing in a certain way or providing the materials that you need. So we went on various journeys with our supply chain. We had a few different workshops, and also some success stories. So we had a lighting supplier that we used in the UK. And whilst we've used Philips in the Netherlands, to procure lighting as a service models, we worked with Whitecroft Lighting and actually, engaged them to give us a quote for a performance contract. And whilst that took ages just to sort of get over the line and get them to understand the value proposition to them, we had another opportunity for Cheshire Police Headquarters, which we were managing as an FM contract. We had to change some lighting. So all of the lighting needed to be replaced. It was originally provided by Whitecroft Lighting, let's say 10 to 15 years ago. And rather than just taking that out as we would normally do and throw it away, we basically incentivized Whitecroft to work with us to come up with a better solution. So actually what we did was we kept the carcass and changed the motor and the LED, changed the light fitting to an LED, and essentially that was cheaper than getting the new product in the first place. And also encouraged Whitecroft Lighting to start thinking about how they would take those materials back, and sell that as a product going forward. So that was quite eye-opening, and for Whitecroft Lighting, that resulted in them producing a new product. So they have a new product range as a result of that engagement with us, which is great. And then finally, just looking at procurement models, as I said, whether we've worked on both building projects, but also infrastructure, we've got a range of different procurement routes that sort of incentivized us to deliver a circular outcome. So MV scoring model. So the dike that you can see there, afsluitdijk is called in Dutch. Basically, we put forward our bid, and because there were let's say 20% of the bid was looking at long-term value, so sustainable innovations. Our tender actually went in discounted by that 20%. So again, we won the job based on the fact that we were the cheapest over that whole life cycle. We also produced total cost solutions, agreed profit share. So having that open book policy where you can talk around the table with the client, and actually say, look, yes, we're going to invest our time doing a little bit more R&D, looking at materials that can be reused again. So we used a Philips headquarters in Eindhoven that was going to be demolished. We used the timber facade, so it was a timber glazed windows. We used them for internal partitions in the ABN AMRO pavilion, and also at the pavilion we instigated a review on higher residual value of materials. So again, looking at the materials that we would use on day one, and making sure that after 25 years that they were actually worth more than the standard products that you'd normally build with. And then I think I'm out of time, but just to leave you with a few opportunities, whether it's looking at digital material platforms, which we've done, or looking at different sharing platforms, different types of contracting, so performance contracting, translating material waste into value, closing the loop, remanufacturing, as I touched on before. And essentially there are benefits for the whole team, and it's really around understanding it. And I think, as also just to reiterate, as Elma said, it's probably not, it's quite complicated, it's quite complex to look at circular economy, but I'd say it's fun as well. So I'll leave it there. Thank you.
Thank you very much for that, Nitesh. I think it's really good to sort of be able to delve into some of the ways that you engage with the supply chain and the clients to help realise what value can actually come of these projects. We are running slightly late, but we will run over a little bit to answer a couple of questions that we've had come in. So I think we've got one from Georgina to Elma, which is what additional time and scope should clients allow for to enable reversible BIM analysis to take place, and who in the team would usually take ownership of this?
Yeah, good question. So I believe in the future we are working on protocol for reversible BIM. This is how you build up reversible BIM. Obviously, the way a BIM is made now, if you use Revit, a model you create with Revit, cannot be used 100% for analysis of reversibility. So that's why I decided to develop a protocol, so that when you follow the protocol and build your model according to the protocol, then the assessment is done within a couple of seconds. So I don't think that the time will be a question in the future. It's more the skills, and that we have to get used to work in different way. Of course, we do still need some additional work, but I think within a year or so we'll have quite functional plugins to be used. So once model is there, done according to the protocol, the assessment itself runs automatically. Is that the answer to the question?
Yeah, I think so. Yeah, thank you. Nitesh, you referenced the valuation model, the 50% land value, 50% non-financial metrics for the project in the Netherlands. What other policy in the country that you have worked in would make it easier to enable circularity at this stage?
Yeah, it's a good question. And, I think, there's a lot we can learn from different countries and their approach to procurement. And I'm actually part of the development of the Construction Innovation Hub's Value Toolkit. So I'm leading on natural capital for the UK GBC. And that certainly has the merit and the sort of the tools, will be developed around that to start thinking about how the UK market can start to incentivize or change contract types, etc., to look at, looking at the sort of benefits of human capital, social capital, natural capital versus produced capital, and actually putting something together that sort of gels them all together so that we're not just thinking about short-term gain, we're not just thinking about financial capital alone. So I think hopefully that's coming. But yeah, I think it is, we do need a step change. We need a change in the way that we currently contract, because it's still, even the examples that I've shown, having developed them over the last 10 years or so, some of these projects, we've had the ethos from the client, but ultimately we've been employed, generally speaking, except for one example, generally we've been employed on the same basis, i.e. we still want you to give the lowest cost, even though we're, you're giving us a circular product, and that needs to change.
And perhaps one for both of you to answer, if you may. Since reversibility will happen in 30 to 60 years' time, how do we ensure that the right information gets to the right people in the future so that existing components are redistributed to the stakeholders for reuse?
Very good question. Obviously, the one thing, there are different things that need to happen to have a good information share in the future. To start with, I believe that BIM will be a kind of storage space. Digital twin will be there, and we'll have to figure out from technological point of view how to preserve the data and digital data with blockchain technology, fix it, and it will be used. Another important thing that is important to have in mind is that the manufacturing industry will be taking much more important role than it has now. And obviously, we've been talking about some business models and service contracts and these kind of things. So the manufacturing companies and manufacturers will be more related to their products through their whole life. So they will not stop having contact with their facade system once it's produced and left the factory. And I think that will also be an important incentive for the future, that we'll know who produced it, and there is kind of responsibility of the producer to take it back when it needs. And just one example of that, there is a consortium made here in the Netherlands of facade companies, producers of facade systems, for the take back surface contracts. And they made also agreements, mutual contracts, to cover each other if one of the company would not exist in 20 years, for example, that the other manufacturer will take their systems back. So I think we'll see more and more of this in the future. So two sides: one, the producers will be more involved and will be taking their products back. And second, the BIM, I think the way we cluster that and save in a virtual twin will be an important one.
Yeah, thanks. Nitesh, did you want to add something to that? Or
I mean, just to reiterate Elma's thoughts, I think data is key, and whether that's using BIM to put in the data, whether it's design data or probably more so manufacturing data. Material passports have been talked about, and certainly through the Bambi project that both Elma and I worked on, the team developed a sort of prototype or a template that could be used further. That hasn't really taken off so far, but I think a version of that needs to exist. And then I think that the data capturing will help us to be more proactive around the maintenance requirements. So it's not just about taking materials away the end of life, but also about how FM contracts manage, or clients manage, the information, and whilst they're also managing their building, to ensure that they're being more proactive around the maintenance regimes, etc., keeping the information up to date, and then obviously passing that information to a new owner as well. And I think there's a huge potential, having worked on developing a material exchange platform in the past, and there are other competitors and sort of people trying to do the same thing, but there's a huge again, going back to business model, there's a huge opportunity, because in the Netherlands we have a function, the term demolition contractor is going away and it's being replaced by urban miner. So essentially, a company that's going in to look at how to retrieve the wealth from existing building assets. So that's one thing that could happen for the next 60 years, but I think we need to look at things that are already built now. And I think Elma mentioned digital twin as well. So looking at things that have been built 50 years ago that currently need replenishing. I think we can do a lot with data and then sort of managing that material exchange now.
Yeah, excellent. So thank you very much. Thank you very much for that. Any of the questions that we didn't get to, you can post in the Miro board, and they can be sort of answered at a later stage. So apologies if you have answered questions, we haven't got around to it, but the next event will be stage 5, and that'll be on the 25th of March, and you can go grab a ticket on that now. It's on the Eventbrite page, and we'll be focusing on sort of circular economy principles and how they can be established within manufacturing and construction, which has also been addressed partially today as well, so that's great. Finally, a big thank you to our speakers, Elma and Nitesh, for their insights, and the ACAN team behind the scenes, and all of the attendees. Thank you for joining, and I hope you will have a good afternoon. Thank you.
Thank you.
Thank you for hosting it. Thank you.